Okay. Section 8.4, we had a couple things going on in section 8.4. We have vertex form and determining whether or not a function is odd or even. And if your 8.4 notes aren't out, I would suggest getting them out. I've got the equation for number 14, w of x equals 5 to the x. I don't have to put this on a physical graph, don't have to graph it on paper, but I got to look at it to decide if it's odd or even. And in the case of this one, I'm going to sketch it right here. It's looking to me like this is an exponential curve from just what I'm seeing. It's an exponential curve moving up like that. And I can tell that it's not symmetric about the y-axis, so that means it's not even. Then I think about, can I take this curve and turn it 180 degrees? Well, if I did that, one turn, another turn, it's going to be coming down here. That would make it odd. My only conclusion on this one is that it's neither. Only conclusion on that one is that it's neither. Now, you will be able to use your notes. Just make sure that you can get at where all this information is. Because if you don't know where to find things in your notes, you're not going to have the time during the test to do that. I'm going to go on to number 15. Number 15 is negative 8x. When I look at the graph of this one, oh yeah. So this is a linear graph, but this one is actually going through the origin. And since it's going through the origin, this makes our rotating of this a little bit more obvious. I wrote this, actually this is all I did on a note card to double check it, or on a sticky note. I did this earlier. I went, okay, here's my line. Oh, it's actually going through the origin, that matters. Going through the origin for sure. And then I went, okay, if this is where I'm starting, what if I turn this 180 degrees? Look at, it's right back to where I started. So if I can rotate it 180 degrees around the origin, that makes it an odd function. 180 degrees around the origin. But the thing about this is be careful, because not all linears are odd, but the ones that go through the origin are. Not all linears are odd, but the ones that go through 0, 0 can be turned 180. And then last but not least in this odd even group, I don't know if anybody's paying attention to my calculator. I have a bunch of problems lined up in here, and you can turn graphs on and off by pressing enter on the equal sign, and it can change from one equation to the other. So all I'm doing is going down and choosing another equation. This is the 3x squared minus 2x. Number 16. We got a parabola here. I would think differently if this vertex was at 0, 0, but I think this one is neither, because I can't fold it on the y-axis. The vertex isn't 0, 0. If it was, I could. And if I were to rotate this 180 degrees, it's just going to wind up upside down. So this one is neither as well. And I did have you guys get your quizzes out, because there were some of these on your quizzes that we could look back at after this. And then the only thing I want to do with my little sketch of this one is show that the vertex isn't quite at 0, 0. It's a little off to the right. That one is neither as well. There's a couple of those on your test for sure. Now, when we go into 17, 18, and 19, I've got those graphs presented already. Actually, I had an Algebra 2 kid that helped me out and did these for me. So this is the graph of, here's our parent. I put this on the parent functions graph. Here's the 2 times x minus 4. Oh, I see, he's got points up here. 2 times the quantity x minus 4 squared. That minus, what is the 2 on the outside? So there's different things we got to talk about. Everything needs to be compared to, what if it was just simply x squared? So the 2 on the outside is going to make this skinnier. The parabola is skinnier. We call it skinnier or narrower. And if it gets narrower, it's considered to be a vertical stretch. It's stretching towards the y-axis. Narrower than the parent. That's from the 2. We call that a vertical stretch. And then inside the parentheses here, it had the x minus 4. And it was the x minus 4 that moved it right 4 units. And we talk about that as a horizontal translation, 4 units right. So again, anything going on in the equation other than the x squared needs to be addressed. When I look down at number 18, this one, a half of x minus 1 squared in parentheses plus 1. Got more to talk about here. This is wider because of the half. This is wider because of the half. It's a vertical shrink when it gets wider. Wider than the parent. That's from the 1/2, bless you. We call that vertical shrink. And then the x minus 1 inside, this 1 is responsible for moving it to the right one. So we've got a horizontal translation right 1. And there's one more thing going on here that you need to make sure you talk about. You got it. And that vertical translation up 1 is from the plus 1 outside. This inside moved it right, this outside moved it up. Vertical translation up 1. There you go. All right, now 19. The opposite of x plus 4 squared plus 7. So if I think about this in parts, it would be that opposite piece that would take this initial parent function, flip it over. This plus 4 inside moved it to the left 4. This plus 7 outside moved it up 7. Every component, and I think this is going to help you guys look at your quiz corrections after this too, just to see what you're missing. I've had some people ask me, why is this highlighted? You got to go back and talk about each piece. The negative reflect over the x-axis. The 4 plus 4 in here moved it left 4. So we have a horizontal translation left 4. And you have a vertical translation up 7. You have at least 2 problems like this on your test. And the parent isn't there for you, so you're going to have to put your parent on the graph and then make the comparison. Bless you. And I want you guys to walk out today with all of your review stuff stapled together and ready to go. I'll meet you at the door tomorrow to collect your reviews, and then you'll sit down with your notes at your desk and you can use your notes on the test. We skipped over number 20 and 21. Not tested on those, not looking at them. 22. There we go. I've got my 22 on my graph already. Graph the quadratic, label the vertex, axis of symmetry, and x-intercepts. Do the domain and range. Definitely questions like this, too. I put these on with my parent. They didn't need to be. It didn't need to be compared to the parent because there was other things going on in here. So it asks for label the vertex. The vertex of this one is 1, -9. That's my vertex. I'm going to highlight the graph itself. Thinking about the equation, this is in intercept form. That's why it hits at 4 and -2. Hits the x-axis at 4 and -2. The vertex is 1, 9. That makes the axis of symmetry. The vertical line x equals 1. That axis of symmetry could even be drawn on there. You could grab a yellow marker and put it there. There's my line of symmetry for the parabola. What else? X-intercepts. My x-intercepts are sitting here. X-intercept is at 4, 0. The other x-intercept is at -2, 0. The other name for x-intercepts is zeros. Zeros. Make sure that you're using those interchangeably. What else? X-intercepts, domain, and range. As far as the domain is concerned, this problem doesn't have any context, so I'm going to assume no matter what, I can put any x value in. I'm going to say x is all real numbers. Y values, on the other hand, only go as low as this minimum. Y values only go as low as this minimum, so that makes the range. Y values have to be greater than or equal to -9. Y values have to be greater than or equal to -9. Lots going on in this one. Vertex, AOS, zeros, domain, range. Not to mention even getting it on your graph correctly. Number 23, same idea. I'm going to go in. Again, you do not have to have these on with the parent functions. I just used this graph paper because it was handy and I had space on the back. There's my parabola. Just checking out this vertex. The vertex looks like it's at -2 and 3. Vertex, -2 and 3. Axis of symmetry equation comes right from there. X equals -2. Make sure that you're putting the x equals, because that's the equation of a vertical line. Then I've got to go find my intercepts. My x-intercepts looking like they're at -3 and -1. -1, 0. -3, 0. Those are my x-intercepts, otherwise known as zeros. Domain, no reason to believe I can't put anything in for x. All real numbers. Range, this is a maximum because it's the highest point. The highest point for y is 3. Range has got to be less, y has got to be less than or equal to that 3. Below that, all values for y going down. Number 24. I'm going to keep moving along. You guys can spend more time with this later. It'll be posted publicly. Number 24. Let me just highlight my graph. Put my axis of symmetry on there. Vertex is looking like 4, -1. Is that right? Okay. That makes axis of symmetry equation x equals 4. My zeros are sitting at, looks like 3 and 5. Yeah. 5, 0, 3, 0. Those are my x-intercepts, aka zeros. No reason to believe that I can't put any x value in for the domain. It's only when we have a problem that's in context with these quadratic relationships that we would change our domain, like the time or something. And then we have a minimum. The lowest y value is -1. So the range is y is greater than or equal to -1. Y is greater than or equal to -1. And then 25, 26, 27. I don't think that I have those graphs yet because I just wanted to make sure we reviewed together finding zeros from our calculator. Find your 25, make sure it's labeled on your graph. I'm just going to go find where this is in my calculator. I already had this equation in here to use. -2x squared plus 6x plus 8. -2x squared plus 6x plus 8. I'm going to go to the table of values for this. It said use zeros to graph it. So I'm looking for the values when y is 0. That's -1 and 4. Yeah. I sure do. Come on up. Right over here behind my desk. -1 is one of the zeros. 4 is one of the zeros. I'm using that to graph. Now, I'm not going to go, you see it? I'm not going to go too much, I'm not going to go dancing around to figure out what this vertex is, but I know the vertex is between 112 and 212. So if I go put this on 112, 212, this thing talked about these directions, I can't even go to 12. I'm going to go up here. These directions said use the zeros. So you don't have to get too crazy about that. I'm just going to go a little bit higher than that. And I've got that on the graph. Use the zeros to graph. I didn't know the vertex, but I know it's between those. So that's the best I'm going to do there. No reason to take that any further. I'm checking out your graphing abilities in other places. This is a test whether or not you can identify zeros. There's my next one. X squared plus x minus 2. I'm going to go to my table, look for those zeros. Looks like the zeros are at 1 and -2. 1 and -2. And actually, these other 2 points, I'm in the same boat I was. At -1, I go down to -2. At 0, I go down to -2. I could grab a couple other points. -3 goes up to 4. 2 goes up to 4. And based on our experience, I know darn well that our vertex is falling here. So when I go to just like draw this in, I'm just going to drop between those two. Vertex is falling in there. Using the zeros. 27. Oh, I didn't write this one down. This is not a quadratic. The 2x to the third minus 18x. It's not quadratic, but we've seen ones like these before. find that one in my y equals. There it is. So just I'm stopping off to look at this. This hits the x-axis 3 times. It looks to me like it's at, yeah, -3, 0, and +3. When I go into the table, -3, 0, +3 for sure. -3, 0, +3. And then these other points that I see here aren't helping me much at all. Ooh, wow, -56, it goes up to 20 and 16. The one thing that I can say about this is I know that beyond those zeros, this function's going off the graph, up high, down low. It's just recognizing where those zeros are. Zeros are where it hits the x-axis. So just a sketch of that one will do. We are looking at now number 28. 28 can be done right on your page. Write a quadratic and function in standard form whose graph passes through 4, 0, and 6, 0. Well, they're giving me no choice right now to start out in intercept form. P, 0, Q, 0, and I could put any A value out here. They're starting me out and saying, no matter what, I got to get this in. No matter what, you got to start out with these zeros. So I'm going to write this function. This function is accurate, and it'll hit the x-axis at 4 and 6, written this way. Now, my 1 right now, or my A right now is 1. We could put any number there. Let's just play around with this A1. So we know that it's just like the parent, but it's just going through 4 and 6. Now, this did say put it in standard form. I'm not going to ask you guys to make this translation into standard form, but I'm going to on your test, but I'm going to show you now, because this is absolutely stuff that we're going to be looking at. We can take this to standard form by multiplying those together, x minus 4 and x minus 6. Jot that out to the side. This is like our Punnett square that you guys have done before in biology. Now, you just multiply the dimensions. What's x times x? X squared. Over here, -4 times the x is going to be -4x. Down here, the dimensions are -6 and x. This is going to be -6x. The dimensions of this corner are -4 times -6. It's going to be 24. Now, if I go take all that out of there, I get that this is equal to x squared minus 4x's minus 6x's. It's going to be minus 10x's plus 24. So that is standard form based on what I started out here in intercept form. I expect you to go here and we'll just keep working on this kind of thing. I expect you to be able to write an equation in at least intercept form, but I'm not going to assess you on changing to standard form right now. Now, number 29, just doing this right on my page, and it's 8-6. It's the linear, exponential, quadratic, and you definitely have some of those on your page. Tell whether the table of values represents a linear, exponential, or quadratic function. This looks to me like there's some kind of a division going down, like it's getting smaller, but there's such a big gap between, and I don't see this, so I don't think this is linear. I don't think those differences are going to be consistent, nor do I get the idea that it's quadratic, that it's like going down and then coming back up. So then the question is, what if it's exponential? And if you look back, why don't you guys go into your 8-6 notes? This is important for you to just put your brains and your eyeballs back on things. Looking back at your 8-6 notes, we've got, and I should not be the only one flipping, exponentials have a common ratio. Consecutive y values have a common ratio. This page in your notes, 272. Common ratios, you pick up a y value and you divide it by the one before it. 128, I'm going to actually come down here. 128 divided by 512. That's a fourth. When I do 32 over 128, that's also a fourth, or 0.25, a quarter. 1/4, a quarter. When I do 8 divided by 32, that's also a quarter. 2 divided by 8, that's also a quarter. Since these are all equal to 0.25, what we can say then is our common ratio is 0.25. And when we start out at, you know what, I didn't have you guys write any exponential functions, so I'm not going to worry about this. This is going to be our common ratio. Do I expect you to do linear functions and y equals mx plus b? Sure. You don't have to write an exponential, but you can identify it by saying it's as a common ratio. And there's no sense in me taking this further because I'm not testing you on exponentials. We haven't practiced any of the writing of those either. Common ratio, this one is exponential. I would expect you to write a y equals mx plus b for a linear. Now number 30 gives you a situation, and I know I've written all over mine, but hopefully this isn't the first time you're looking at it. In number 30, we've got the balance of your savings account after t years is represented by y equals 200 times 1.1 to the t, where t is years. Y equals 200 times 1.1 to the x we could use. The beginning balance of your friend's account is 250, and the balance increases by $20 each year. Compare the account balances by calculating and interpreting the average rates of change from 2 to 7. And predict which account will have a greater balance after 10 years. So I'm going to actually turn my paper sideways, and I'm going to go put number 30 over here. And I'm going to set up a table that is years, 0. They want us 2 to 7, but I need to get that 0 and 1 in here as well. And then this is your savings account. Now that is the y equals, what is it, 200 times 1.1 to the x. And then underneath here, it's going to be your friend's. And your friend's account doesn't have an equation, but what we know about the friend's account is he starts with 250. And then his balance increases by $20 every year. 250 plus 20 is 270. 270 plus 20 is 290, 310, 330. I'm just adding $20 each time. 350, 370, 390. Now, as far as the my account is concerned, your account they're calling it. As far as that's concerned, I have the equation. I think I put it in my y equals already. I did. So going into y equals, I've got it here, 200 times 1.1 to the x. I'm going to go look at the table. At 0 years, they started out with 200. It's interesting because that's in the table too. After 1 year, that's at 220. After 2 years, I see it's at 242. And I'm just using the values from my table. After 3 years, sitting at 266.20. 4 years, 292.82. 5 years, 322.10. 6 years, 354.31. 7 years, 389.74. Now, they wanted us to look at the comparison of these two accounts between 2 and 7 years. And let me go back and read what the question was asking. Compare the account balances, calculating and interpreting the average rate of change from t equals 2 to t equals 7. What I'm seeing here between 2 and 7 for your friend's account is there's a constant rate of change. The friend has a constant rate of change, constant rate of increase of $20 a year. Now, when I look at the account here, this actually is growing exponentially because that 200 is being multiplied by 1.1 each year. 200 times 1.1 is 220. Then it's 220 times 1.1, it's 242. Then it's 242 times 1.1, it's 266.20. So this is going up a little bit more each year. So this one is growing by 1.1 times each year. It's an exponential. So the increase each year is a little bit more. 1.1 times 220 is less than 1.1 times 242. You know, the increase is going up more and more. And then I think the last question related to this is, what do you think is going to happen? Predict which account will have a greater balance after 10 years. How much is this going to go up by in the next year?
410.
It's going to be up to 410 if I go to 8, but I'm thinking that maybe this is going to overtake it. Look how close it is. I think your exponential growth, 8, yeah. At 8 years for this one, I'm already up to 428.72. And it's going to grow more and more each year. Which account is going to have a higher balance after 10 years? It's going to be yours. Yeah. Your account will have a higher balance after 10 years because it's growing exponentially rather than constant. Your account. Exponentially. All right. Now this video will be public today. And the other video from 1 to 13 was published yesterday. Use it